Um, Before I even introduce myself here, I'd like to really pull something out of Nolan's talk that I think is really important to understand when we're talking about Alaska in general, is that he used the word pragmatic, I think, at some point in his presentation, the pragmatism of people in any situation that in which you can find yourself and you're talking about energy. Rather, if it's a remote village, one of the hub communities through which you must go to get to many remote villages, or if it's, in Midtown and Anchorage, right down the street here, the ideologies around certain energy sources and everything, they kind of fall away a little bit. People realize that folks are doing what they need to do to survive, and however it is they can do that, especially affordably, they're willing to give it a try. And I think then that gives a certain framing to Nolan's remarks here that, if the answer in terms of policy at COP, in COP discussions or in the EU or in a White House briefing room, if the focus of that policy discussion is renewables now, no more funding of certain energy sources or technologies, here in Alaska, we have a much more pragmatic view about that transition. However, that's a very organic process of transition. It is not planned, as Nolan mentioned, and that's because that's going to result in some unevenness in terms of what's available in certain regions and that kind of thing. You'll see that theme, that pragmatism, in dealing with just whatever situation they're in with some really organic, ad hoc type solutions. You'll see that throughout this presentation. It pops up as a theme over and over again. So, title here is Climate Justice and Impact of Climate Change in Alaska's Rural and Remote Villages. My name is Jennifer Rachels, and as I mentioned before, I am not an engineer. But as I tell you a little bit about myself, that's going to provide some context for my perspective here, I'm going to sound a little bit like an engineer, especially as you hear like where I went to school and what I studied. So I'm a returned Peace Corps volunteer. I served in Romania, where I helped put in the bid to get money for and then actually install a sewer system, the first sewer system in the town where I lived, Roman, Romania, up in the upper, like the northeast corner of Romania. I worked at affordable housing in the state of Georgia with a focus on rural areas and in zip codes that really needed assistance in urban areas. So the hardest to serve folks when it comes to housing. And I'm also an Army veteran. There are actually a lot of people who were in the Peace Corps and the Army. And when I was in the Army, I was enlisted. I was a heavy equipment operator, and I actually installed solar panels in Afghanistan. So I've really seen how the sausage is made in terms of our energy system and energy use and things like that, and infrastructure development. The Army sent me to Oahu, and I just refused to leave for obvious reasons. And that is where I went to graduate school for the first time. And I ended up with an MBA and a master's in sustainability from Hawaii Pacific University. And things really got out of hand, and I am a PhD candidate at Michigan Tech. It's a pretty well-known little engineering school in the Midwest. But the work that I did there was not in engineering. It's in the social science department. It's very interdisciplinary by design. They refuse to turn out social scientists that aren't involved in advising energy projects. And they're refusing to turn out engineers, don't understand the social context of the work that they do. And so it's a really unique place to go to school and to learn as an engineer and as a social scientist. Right now, I work for Idaho National Lab. And as all of you know, we are deeply involved in the small modular nuclear reactor development side of things, especially in Idaho, where we have the huge test bed facility for vendors. Outside of Idaho, though, our work mostly consists of the sort of things you learn when you're working on small modular nuclear reactors and on nuclear technologies, like systems integration, cybersecurity, grid stabilization. I don't know if I said, I did say integration. So that really goes directly to our challenges here in Alaska, not just the small modular nuclear reactors that are a bit down the road in terms of deployability, but all the technologies around that are deployable now. So I have a little, we'll return to that theme at the end there, but just to let you know a little bit about why I'm here and what we do here, that's that. So next, please. So this is New Talk. Has anyone ever heard of New Talk? Okay, so if you've spent any time in Alaska, New Talk comes up quite a bit. They seem to be the poster child, unfortunately, for village relocation. Village relocation is happening in Alaska because of permafrost melting and the problems that causes to things like water pipes, the condition of your home. As you can imagine, when the ground starts going like this. But then there's also things like saltwater intrusion into your water system that can occur, and susceptibility to other types of flooding, because what used to be a very predictable ice melt is no longer so predictable. And so now you have 500-year floods happening every 3-4 years. I have been in villages that had an ice melt that it was the third time they had experienced that 500-year flood in like 10 years. There was not a single unaffected structure. And again, it was the third time that it happened in 10 years. So how do you worry about energy in a situation like that? You know, what are you going to do with solar panels in a situation like that? These are just things for us to think about. That's what's going on in New Talk. If you have a chance right now, some people have their computers open. You probably do at home too if you're on looking at a Zoom. You might want to actually pull up Google Maps and take a look at where New Talk is and look at the map in terms of all the water that's like interspersed in that area. So, you know, it doesn't take much to flood out New Talk, and they actually don't have a lot of solid ground right now. They started with about 300 people or so in 2020, I think the census said. Now they're down to 33 because they're slowly moving to another village as part of a relocation program. The choices are either to relocate entirely, which is what New Talk is doing, and they have other villages that are doing what some people call it a managed retreat. There are other names for it depending on the perspective from which you're involved in the process. But essentially, the managed retreat is to take just one section of the village that's most at risk away, maybe put it on the other end and extend your utilities out a little bit and kick the can down the road. The relocation folks can no longer do that. What you might not see here in the room is there are little lines everywhere. And it'd be easy to say those are probably dirt roads. But I think it's really dry in here. Ooh. But because I've been to New Talk, I think it's just as likely to say that those are wooden planks, sometimes constructed, sometimes just laid on the ground, so that people can actually walk without them. The silt that's wet, it's like you put your foot on it and go like this, you can watch the ground vibrate. So how do they get heat? In a lot of cases, they fly it in. They can also barge it in. You heard Nolan describe that process. A place like New Talk, though, you know, have to remember in Alaska, we missed rural electrification. We weren't even a state yet. So the investments of, in some cases, running water and electricity are happening right now. The investments that we got at the beginning of statehood, at the beginning of statehood and between statehood and now, have been uneven and sometimes with inappropriate technologies for our region, again, as Nolan pointed out. Housing in particular, we have houses built by HUD here that were probably ill-suited for the winters of Ohio. And we have thousands of them here. And they're in pretty poor condition. So So that's new talk, and I wanted just to talk a little bit about it because, that's really, as we're experiencing these generational investments in our infrastructure development, do they miss out? They kind of are. So, and this is why a lot of the money that's coming down the pipe for this, it comes with a limit. Like you have to spend it in a year, 18 months, 2 years, whatever. And logistically, how are you planning to get all of the building materials to that place and find the people to build the structure, the facility, to put in those pipes, whatever it is, in that amount of time in Alaska? It's just not possible in these locations. It's extraordinarily difficult. And just like you all know, in terms of project management, you can do something within budget, on time, or to specification or standard, and rarely can you have all three. So maybe you could get it done if you had, unlimited money with which to achieve these things. So that's the general operating picture that you're dealing with here in terms of, you're sitting in your lab or you're interacting with people in meetings. The things that you're talking about are deployed in communities that are facing issues like this, right? And for folks that aren't from Alaska, I just wanted to level set here by talking about New Talk because they're not alone. This situation that they're in is replicated hundreds of times, if not more, all around Alaska. The good folks at AVAC doing God's work, bringing utilities to villages like this, and with some incredible technologies all over the state. I watched a 20-year-old in Kotzebue manage her village's solar panel installation that was miles away on her telephone the other day. I think her village has about like 70-something people in it. She sat in a meeting and, you would have thought she was playing like Candy Crush or something. And AVAC enables some of that work. So let's see, next slide here. So what does it look like to govern, like to make decisions about who gets what and where and when in Alaska? We have a very serious situation here with fishing. I encourage you to look it up because I think it's fair to say that a lot of our energy development, whether it be critical minerals mining to enable a lot of the technologies that we need, or if it's the installation of a utility scale solar panel farm on some of the only land that's available for both housing or food or anything else, right? A lot of it comes down to water management and fishing because subsistence here is extraordinarily important. If folks, during the shoulder seasons in particular, don't have the opportunity to get the moose, caribou, or in other parts of the year, the fish that they need for the rest of the year, you're in trouble because there's no other way to get it. The barge quits running. Everything's frozen. These are really important issues here. So it's not, really a matter of, environmentalists coming from Colorado to raise cane about some project because it puts too much silt in the water. We're really talking about survival here for folks. This is a very, very serious issue. And so that's why I have that up there. But I also wanted, about intersecting issues with our energy things, but I also wanted to show what the panel looks like of people that are making those governance decisions up here, to have all the pieces of the system in the room, the user, the commercial user, local government, individual hunters and fishers. That's what a panel looks like up here when we make governance decisions, because frankly, our state government doesn't provide a lot of leadership. There's a big hole where in many cases you would encounter state leadership in policy issues or installation of infrastructure projects. If you find yourself working in Alaska a lot, I highly encourage you to learn about ANCSA and our native corporations, because nothing will get done up here without a full understanding of our governance system. And I say that very carefully. I didn't say government, right? We have a governance system here in Alaska. You have state government, which leaves a vacuum a lot. You have boroughs, which can be, you could look at it and think of it as like a city, but then in other cases, it's more like a county in terms of how it operates. It's different in every place. Every borough has a different way that it operates, really, and it can mess with your understanding of an analogous situation, you know, of where you're from. So you just have to really take it case by case. And then you have native corporations at the regional level, some of which provide all of the utility services for that region and run hospitals, which are incredibly energy intense, right? And you have smaller corporations for individual villages sometimes, and they will often get together and form a group that also provides utility services. And then on top of that, you have things like ABEC. It's extraordinarily complicated governance system here for our utilities. So that's why that's included, that picture there. And then theoretically here, we'll talk really quick about the idea that justice, it's not like a airy-fairy idea. You know, people hear justice these days and it brings up a lot of like ideological conversations. Justice is a policy issue. That's what you're really talking about here as it relates to justice and policies. The idea of, you know, so scale, we're probably familiar with this, right? Policy has three goals, right? To determine scale, allocation, and distribution. And justice applies to the distribution aspect. Who gets what and where and why and how much, all of that is a distribution issue. That's what policy does. And that works on a time continuum as well. It's not, you know, the whole justice aspect of, you know, this group of people are going to get more attention right now in terms of financial support for the projects they need because they need to relocate, for instance, like Utah. That means necessarily then that money will come from somewhere else. And those trade-offs that happen, we don't really tend to think about it this way, but justice also applies to what we take from the future. And that is why some of the, there's a lot of discussion about youth banding together and, you know, suing in some state courts, and that, you know, some of the things that are being done now in terms of policy are denying them opportunities in the future. That's the undergirdment of that movement. But it's a real issue in terms of policy. You have economists that spend their entire lifetimes doing that kind of work. Next, please, next slide. So this is Kotzebue in Northwest Arctic Borough. Let's talk about their population a little bit here. I have it written down. 2,983, I think, as of like March of last year. And Kotzebue is right down the road in Alaskan terms anyway, from Good Hope, or is it Point Hope? And Chariot. So there is a great book called Firecracker Boys, and it's about Project Chariot. And that's a grand idea of a gentleman in the precursor of our Nuclear Regulatory Commission, if I remember correctly, who thought it would be a great idea to see if it made sense by doing it, to create a bay by exploding, I think it was 6 nuclear bombs in a row to basically dredge. You could accomplish that by exploding 6 nuclear bombs in a row, and we'll just see what happens. And hope it works out for us. And we laugh at it. They were this close, folks, this close. And there are people that suffer in terms of their health and their property and everything to this day because of that. And it was it was one of those things in the policy they called a zombie policy or a zombie project, where it was killed in many different avenues and it just wouldn't go away, to the extent that some of the people who thought it was a good idea moved up to the area so that they could continue to do the work anyway when they were told not to. So imagine what I own. Whenever I walk into that space, I own that story. Doesn't matter that Idaho National Lab didn't have anything to do with it. I own that history when I walk in here. And so that's what I wanted to mention to you all here as sort of the big takeaway when we're talking about the effects of climate change on Alaska Natives in particular, but people in rural remote villages in general. So the people who caused much of the issues that they're seeing in terms of climate change, it's not them. Their energy usage and their carbon footprint of the lifestyles, even with diesel, are minuscule compared to mine. But they bear almost all the costs of the decisions that we've made. And so when we talk about, you know, equity in terms of the money we're going to spend and things like that, you know, it's worth it. And it's the idea too that these spaces have been used for experimentation as though no one lived there for a very long time. So that's going to affect why people will reject or accept certain technologies. People, you know, we have researchers in general, we have a tendency to believe that if renewable energy is great, right? Only good things. Well, maybe not. If you've been told over and over again throughout the history of your town, for instance, that, you know, we're going to bring, this mine's going to be great. It's going to bring so many jobs. And then 20 years later, it's, you know, this gas field is going to be great. It's going to bring so many jobs. And now somebody comes and says, oh, these solar panels are going to be great. They're going to bring so many jobs. It's just another story. And especially if you work with a government agency, there's no difference in people's mind between the homes that they received from HUD that we now know are inappropriate technologies and failed wind developments from the past, even though the technology is totally different now. You know, you're coming in, you're talking on behalf of BIA, Department of Interior, or Department of Energy. Everybody wears the same coat. You can't come as a representative of the United States Department of Agriculture and not own the Department of Energy's history and story here. So everybody owns that if you come and say, you know, I'm here to help. And so that brings me to another issue in terms of some of the drawbacks or things to look out for as you engage with communities related to technology development and social acceptance and things like that, because you will if you want to work in this space. And that is that we have a hubris, and we should admit that we know the answer. And in fact, I personally believe, and I have seen that the answer to many of the issues that face Alaska already live in Alaska. This gentleman here from Dillingham, right? The idea of somebody just, you know, flying in and saving the world, you know, it's a little suspect in the eyes of people born and raised in Alaska. And I think that when you talk about solutions, then you understand on a really practical level, well, that having all people at the table is really important. Your PhD electrical engineer and your villager, regardless of their level of educational attainment. I'll give you an example of this. When I was in Kotzebue, I was in the Northwest Arctic Borough Energy Steering Committee, a group, by the way, which does not actually exist on paper. Is an organically developed over the course of a few decades governance system that operates by consensus. legally does not exist, doesn't own anything, doesn't run anything. But that's how decisions get made here in Alaska, okay? But I told you about the young lady managing her solar panel or villages system here on her phone, you know. But another thing that happened in that same meeting was that there was a graduate student from University of Vermont who gave a presentation about, it was a model. She described the model in terms that made my eyes glaze over. So dry, y'all. You probably would have loved it. I was miserable. There are a few other people in the room that were just like head back, mouth open, you know, eyes rolled back. There were two gentlemen from a village about a 20-minute plane ride away who had flown in that had been part of this group since its founding about, I think, 30 years previously. He was an older gentleman too, probably in their 60s, mid-60s. And when she finished her presentation, they raked her over the coals. She at one point she had her computer open and they were looking at data. And they were telling her, this is what's going on here. We suggest this. And they were pointing at parts of her model at individual inputs. And I think that she felt it was responsible ethically to give the results of her PhD research there to the people that were part of the data that she collected. I don't know if she anticipated that interaction. And I would like for each of us who work on the issues in communities here in Alaska to plan those interactions into your work. Okay, and not to view engagement as a barrier to overcome, but to understand that it, you know, community engaged research and justice, energy justice, you know, these are not fads, you know, wave them away, you know, change in administration changes the policies and it goes on forever. It makes your data better. It makes your model inputs and outputs better. It helps you analyze better. That's why this is important. It's not just, you know, like I said, an airy-fairy, you know, good idea, nice thing to have. It's required if you want to do good work. One of the things we're talking about in the labs right now is this idea that we want to do community engaged research and, you know, everybody, let's start thinking about that. And as engineers, that's pretty exciting work. You finally get away from your desk maybe, right? But the issue from the social science perspective is that social scientists understand community engaged research as the work of a lifetime. And that requires a relationship with a community that will last your entire career, that you'll never leave, which is a little different than how engineering is set up as a discipline. Like, you know, dang it, I build bridges and I build the best bridge I can everywhere I go. And social scientists are like, I know this place in this space and understand the social network there and the power structures there and how that affects their decision making and their legal system and how they govern their water system and all of those things. And I don't know jack about the place next door. And so in terms of interdisciplinary work, if you find yourself on a team and you realize you don't have a social scientist to inform some of the things that you do, you don't have folks from the area that you're working in to inform some of the things that you do, you have to make space for that, write it into your plan and your budget to make sure that those things happen. There's also some other emerging justice issues I wanted to bring up, and then we can move on to the last slide here, and I'll sort of wrap it up. One is data sovereignty. We collect a lot of data in our work, engineers even more so. And if that's the case, especially as it relates to collecting data on Indigenous folks, there needs to be a discussion about the governance of that data afterward, how it is available to the public, that has a financial value, who gets that, what gets paid for it. That happens quite a bit. That data is collected on an Indigenous community and then sold to someone else for another reason, and those folks don't get the money. And so that's an emerging aspect of work, especially in the energy system, because if you've ever tried to get data from a utility to do your work, you know how difficult that is. The university system of North Carolina has turned that into an art. So understanding also an emerging issue in community engaged research is extraction through research. What I mean by that is one of two things. One, either the information that's gathered, the research that is done is then used later in ways that surprise the people who engaged in it in the community. So I'm a social science researcher. I'm interested in nuclear acceptance, or I'm an engineer interested in the uptake of certain technologies and why not. And I go to a place, I collect that data, then my university or whatever I feed that energy into, it can even be a platform, that data into, it can even be a platform that then you have to pay for every month, then someone doesn't pay for it, right? That data can then be sold, regardless of how it ends up getting sold. It can then be sold, or it can be used inside it to say, oh, well, you know, we're using that technology, so check the box. We've done our tribal consultation. Because somebody else did it for us as a minor part of this project a year and a half ago when they were asking vaguely adjacent questions. That happens quite a bit. So always be very cognizant of what's happening with your data and with your research, making sure that it doesn't become a conduit for other types of extraction and that kind of thing. So one thing I wanted to point out before we go to the next slide here is that these are operating at about 90%. So there's the like installed capacity, and there's the way they actually operate, right? When it comes to solar panels, these are about 90% of how they operate in the summer right now in a 20-foot drift in Costview. This was taken 2 weeks ago. So this whole like, it's not work in the snow. Garbage. They work. Interestingly enough, too, I don't know if you can notice it here, but there's a little bit of a wobble in these. These are, I think this is the 2-year-old part of their installation. The permafrost melting has caused them to go like this. So the issue in terms of how they work might end up being that their positions move so much because of the permafrost melting. I think we're about 30 miles north of the Arctic Circle here. That it might end up being their major problem over time. And I'll point out too here that they use, talked earlier, somebody asked a question about electric technologies for heat. They use heat pumps in this area. Got some numbers for y'all. What am I doing on time? I'm over. Okay, we'll finish it up here then, because I actually don't even have that much. Total diesel offset after renewable energy sources and heat pumps. They use it on the shoulder season. They don't work in the depth of winter. The idea is not using as much diesel as possible so you can save it for when you need it in the winter. Makes it cheaper. Let's see, they're saving $328,000 gallons a year from electricity, renewable electricity from the utilities. The heat pumps, 90,000. That doesn't include costs of the largest city in the region. So the approximate value of the savings of heat pumps and renewables is $1 million. To that region, that is life-changing money. Next slide. This is the city manager of Unalakleet looking over their relatively new wind installation. And then the town is here off in the distance, on the left-hand side of the picture. And yes, there are structures in there. So they're also going to relocate up the hill. And so when it comes to justice issues too, to take into account the amount of money that it costs to install that wind in a place that now is going to have to move. You know, when you're thinking about technology, that's important. Next. And so we'll close here by talking about you know, saying earlier that yes, the small modular nuclear reactor thing is a thing for Idaho National Lab. The technologies around it that are deployable right now, those are the things that outside of Idaho that are really important, I think, for Alaska. Yeah, the microgrid in a box. So it's the sort of thing where all the connections you need that you would normally put around a small modular nuclear reactor, that would be in the middle. And things like this on the outside, right, that provide like the actual grid itself. Wouldn't that be great if modified a little bit for a village like Newtalk as they're moving to support the folks that are left over? But you have to make sure that that temporary solution doesn't become the permanent solution once they move. So you come up with the best idea that's so innovative and spend all the money in the world making it work to support people. And it can still end up at the end of the day being a bad idea. I don't mean to discourage anyone. I'm just saying that there's a whole life cycle to these technologies, right? And to think about that, we're used to thinking of life cycles for technologies in a lot of other ways, but in terms of justice, we're not there yet. And I challenge you to insert that into your planning processes. Thank you for letting me go over time. I appreciate it.
Thank you very much. That certainly broadened our horizon a bit. So what I'd like to do is actually invite Witold Kinsner to start presenting from online. So from Winnipeg, I believe. So if that works, let's try it. Okay. While you're setting it up, maybe we have time for one question. Okay. Just a comment on your data governance issue. I happen to be on a committee with the Canadian Standards Council, and data governance and AI is very much concerned with the data sovereignty issue. So it's definitely there, and I think there's actually a link posted in the chat to those efforts on the Canadian side. So it might be interesting to actually look across the border and see how people are handling it there.
Also, for people that want a resource to get deeper into that, how collecting data can possibly harm Indigenous communities in particular, especially issues for policy. Kim Tallbear, Dr. Kim Tallbear, she's at the University of Alberta, if I'm not mistaken, and she works in rural sociology there. And she did a lot of work on DNA and indigeneity. And she's engaging in the exact same issues. I was saying Dr. Kim Tallbear at University of Calgary, University of Alberta, sorry. She does a lot of work in the same space here. Her work, though, is in the use of DNA to determine indigeneity. She's a social scientist. A sociologist in particular, I think, but her work is really instructive about co-production and things like that. So especially when you talk about using data for policy, you were mentioning earlier, like data-driven policy, right? It's not always a good idea.
Without data, it gets even worse. Thank you very much.